Good morning, 8th graders. This is Mrs. Thompson. We are back at it again with our video lessons, and we are going to start Chapter 6. As you may recall from last semester, we worked on Chapter 4, Linear Equations, Chapter 5, Systems of Linear Equations and Inequalities, and now we're in Chapter 6. And Section 6.1 deals with evaluating and simplifying expressions containing zero and integer exponents. So we're going to get a break from graphing for just a little while. We're just going to focus on exponents and simplifying those expressions with either a zero exponent or an integer exponent. Okay, now where I want you to focus your attention is right here on this particular first line under the objective where I show you the power, and in this case I have 5 to the 5th power. And if you have your calculator ready, what you may want to do just to verify my number is do 5 root 5, and you'll see, and then hit enter, and you'll see that it equals 3,125. And that is going to be true for each of these other 5 to the 4, 5 to the 3, 5 to the 2, etc. And I just wanted to show you what's happening with these numbers each time, because notice I get down here to this section where we're getting to a 0 power, a -1 power, -2 power, and I want to show you the pattern. What's happening here is go ahead and type in 3,125 into your calculator and then divide that by 5. Did you get 625? And the answer should be yes. Now take your answer, 625, and divide it by 5 again. Did you get 125? And hopefully the answer is yes. And then take your 125 and divide it by 5, and you'll get 25. Take 25, divide it by 5. You should get 5. And we all know what 5 divided by 5 is. And you should get 1. 5 to the 0 should equal exactly 1. Exactly. And then if you continue the pattern and take 1 and divide it by 5, then you'll have 1/5. And then take that and divide it by 5 again, and you'll have 1/25. And so what I want to show you is as you go down an exponent, you're just dividing by that base. That's all you're doing. And when you get to the negatives, it doesn't mean that the answer is a negative number. A negative exponent just indicates that you have a fraction. That's all it is. So here's a couple of things, and we'll see this a little bit more. Here's a couple of things I really want you to know. And as we delve into this a little bit deeper, as we do each example, I want you to know this. Any zero exponent, anytime, any number, any variable, anything raised to the 0 power is always, always, always going to be 1. You don't need to put it in a calculator. You don't need to think about it. If you have anything raised to the 0 power, it's going to equal 1. Always, 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 always. When we get into a little bit deeper into our lesson on exponents, I'm going to try and show you why exactly is that. Why does that work out to be that way every single time? So I will come back to that. I'll kind of circle back around, not this lesson and probably not even this particular section, but definitely circle back around and get to that again. All right, let's talk about negative exponents. If you have any non-zero number, and the book's real specific about making sure that the number is not 0, any non-zero number raised to a negative exponent is equal to 1 divided by that number raised to the opposite positive exponent. And I'll show you what that looks like in example 1. That's actually going to come into play. So if I go back up here and do 5 to the -1, and I follow what this says here, and I go, okay, I'm going to take the number 1 and divide that by the number 5, but instead of raising it to the -1, I'm going to make it +1. So that actually ends up being 1/5, because 5 to the 1st power is 5. And then last but not least, 0 to the 0 power and 0 raised to a negative exponent, they're undefined. You can't raise 0 to the 0 power, and you can't raise 0 to a negative exponent. So it's one of those undefined situations. There's not really an answer to it. So I just wanted to point that out to you in case there was ever a tricky question on there. That would be the answer. It's undefined. All right, let's look at example 1, because I want to go back to this part right here about negative exponents and how to simplify it. The best way I can tell you, the easiest thing I can tell you to do is anytime you're given a base raised to a negative exponent, first of all, identify where it is located in the fraction. Now, I don't see a fraction. 10 to the negative 3 is not a fraction, but I can make it a fraction. I can, very easily. The only way that I could lose that negative exponent is to move it, just completely move it. And so what I'm going to do is I'm going to do what my directions said above, take 1, put that in the numerator, and then I'm going to move that base and that negative exponent to the denominator. If I move it to the denominator, the exponent becomes positive. Okay? And then from here, you can actually simplify. You can go, oh, 10 to the 3rd power, well, that's 1,000. And so really, 10 to the negative 3 power is 1 over 1,000. Now, what if you have an exponent and it's negative in the denominator? So I just showed you, what if it's negative in the numerator? And I showed you what to do. Move it to the denominator. Put it under 1 and move it down. What if it's negative in the denominator? Well, you pop it back up to the top, and that changes the sign of the exponent. And so your answer would be exactly 1,000. So that kind of gives you an idea, some maneuverability, some rules to follow. If my exponent is negative in the numerator, then I'm going to flip it down to the denominator, like I did here. And if my exponent is negative in the denominator, I'm just going to move it up to the top, and that exponent will become positive. And so it's all about moving it across that fraction bar. And if you move it across the fraction bar, the exponent becomes positive. Okay? So let's look at the sandfly that has a wingspan of 5 to the negative 3 inch. So we want to simplify this expression just like we did up top here. All right, so we're going to take 5 to the negative 3. Now, you clearly see this is not currently a fraction. We can make it a fraction, of course. You can put anything over 1. And you see, oh, 5 to the negative 3. The negative 3 is negative in the numerator. So all I need to do is bump it down. So I'm going to put my 1 up top. When there's nothing left up there after you move it, put a 1 there. And then bump it down, and it becomes 5 to the 3rd power. And what is 5 to the 3rd power? Well, that should be 5 times another 5, and you should get 1 over 125, and that's the wingspan. It's 1/125th of an inch. Very, very super tiny. Okay? So that's how you simplify it. Now let me do a what if. This isn't the answer, but what if 5 to the negative 3 was negative in the denominator? Then all you would do is pop it up to the numerator, and it becomes 5 to the 3rd, which is 125. So I just wanted to iterate and reiterate how to move negative exponents so that they become positive. And I hope I was very, very clear with you. So if you have questions about this, rewind, listen to me again. Or write some questions in the margin of your notes and maybe come up with an example that you want me to do, and I'll show you in class how to do that. Thanks for listening.